Well, it looks like I've finally worked out how to use YouTube streaming. Let me chuck that down there so you can look at it. I guess that won't let me do it. Try again. No. Let's try again. Oh, I've just shut the window. So yeah, so this is what I can see. And it was a lot slower than what I was expecting to set up, but it allows me to start streaming on my software, but I don't have to go live until I click go live over here, because a lot of time I click stream to check it's working and I can't see whether it's actually streaming. So this is much better, just taking a bit longer to work out, because they don't actually leave it on your screen easily found. There's no button like go live here. You have to like work your way through it. So I'm going to add this one, this thing to my desktop, and hopefully next time it will be a little bit quicker to get set up. So let's get this out of the way. Let's close that window. Once again, get this blah, 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 done. The course set up, which I'm doing off screen. And we can finally get into some brain ache stuff. Where are we up to? These are all 100%. Right, multiple factors and prime numbers. Here we go. Let's get on with the show now. So let's watch this.
Multiples, factors, and prime numbers.
Factors and prime numbers.
A multiple of a number is a number that can be divided exactly by that number. Multiples are the numbers you find in that number's times table.
Now I need to
the
learn
multiples
that.
of 5 are
5, 10,
5,
15, 20,
10,
25, 30,
15, 20, 25, and so on.
Know off by heart.
The multiples of 11 are
Use the old boogie board.
22, 33, 44, 55, and so on.
Scribble on it and then press the button to delete it.
A factor is a whole number 11, 11, 22,
multiples
33,
11
44,
11,
55,
33,
and so on.
44 and 55.
A factor
So the desktop
is a whole
audio's
number
playing,
that
but I
divides
can't hear
exactly
it.
into another
Why
number.
is that?
The factors
Let
of
me
12 are 1, 2, 3, 4, 6, and 12.
So that means
Because all these numbers divide exactly into 12, leaving no remainder.
Let's try that.
A prime number is a number with only two factors, the number itself and 1. 3 is a prime number because only 1 and 3 will divide into 3. With
I'm going to
no
have to
remainders.
the desktop.
19 is a prime number because it cannot be divided by any number.
We don't want to hear that man talking. And we need to take off monetization as well. We're not meant to be monetizing this. And I need to take desktop audio off. And when I play this,
Other than 1,
I just turn, there you go. So there we go, we got you lot were hearing it and I wasn't. Now I've got to go back again. Let's close that one. Right, I'm ready now. See how boring this is. It's not going to... The number in itself, see, that's what a prime number is. Like 7 or 3 or 1. I can divide 19. 18 for me, 1 for you. 1, 2, 5 and 10, yes. So 1 is not a prime number because it only has a 1 factor. 2 is the only even prime number. So 2, 3, 5, 7, 11, 13, 17, 19. One day I'd like to know what is the purpose of prime numbers. Why do we need to know them? Can continue finding factor pairs until you only have prime numbers to the end of each branch. I don't understand why. To write 24 as a product of its prime factors, start with the smallest prime number that divides into 24 and continue only until you have a prime number at the end of each branch. Well, you best show me that because that means nothing to me. What is the point of it? The prime factors of 24 are 2 by 2 by 2 by 3. And then they're going to ask me to work on this now, and I'll be thinking, why? What is the point? So that's easy. The first 5 multiples of 8. I think I might change my desktop resolution for you guys. Change it to 1080. Got a bit fuzzy, but you should be able to see that much better, clearer now. I think when they designed this work at the place that I'm learning at, they did it on a square, on a monitor like this, rectangular, but they're displaying it all on square monitors. I don't know what's the matter with it. Right, 8, 16, 30. Oh my gosh, see what I mean? I don't even know my times tables. Not 26, it's 26 minus 2. And then that's 24, 34, 32. And then plus 8 is 40. See how slow I am at that? List the first 3 multiples of both 3 and 9. That doesn't mean anything to me. List the first 3 multiples of both 3 and 9. What is the smallest number that is a multiple of both 4 and 6? See, how are you supposed to learn all this just from watching a video? And if I go back, it'll tick them off as don't know. Right, let's go on the internet and find that out. See, list the first 5 multiples of 8, but how do you list the first 3 of 3 and 9? Because that would be like 3, 6, 9, and that would be 9, 18, 27. That doesn't make any sense at all. So you Google that to see what they're trying to get at, because that's the only way you can learn from these. It didn't say the common multiples, did it? In there, it just says the first 3 multiples of both 3 and 9. That this, it just like makes things more complicated. Look, multiple of 3, 3, 6, 9. Multiple of 6, 6, 12, 8. Multiple of 9, 9, 8, 27. Common this isn't even what it's asking. It's not asking for the lowest. It's just literally saying list the first 3 multiples of both 3 and 9. Well, the first multiple of 3 is 3. The second is 6. And the third is 9. And that will be 9, 18. It doesn't make any sense. What is the smallest number that is a multiple of both 4 and 6? 2. Like 2 times 2 is 4. That has to be all wrong. Yeah, 12. Yeah, look. 9, 6, 9. What on earth does that mean? If I can understand it, that'll be handy. So the first 3 multiples of 3 and 9, it says it's 9 there. So that would be... Where's my... But then why do we get 18? 2 9s are 18. So it does mean common then, doesn't it? Yeah, and 4 is 6. So you need a multiple of, so what it's saying, what is the smallest number that is a multiple of both 4 and that? So you'd have to do 4, 8, 12 is the smallest. So the smallest one of that is 6 times 6. No, 1 times 2 times 6. 8's 12. And 2 times 4 makes 8. They don't make any sense. 4, 8, 12. Oh, I see. So you've got to multiply that up until you get the same as that one, of a multiple of that. So if you go 2 times 4, that's 8, which isn't that. So then you go 2 times 6, which is 12, and then you can get 4, 8, 12 on that. So the answer would be 12. And on this, 3 and 9, 3, 6, 9 is the closest you can get. So 1 times 9, and then this one is 18. 3, 6, 9, 12, 14, 15, 16, 17. Oh, it's 9. It'd be 1 again, wouldn't it? Why can't it just be a 9? 1 times 9. Because 3 can't be 1. One times 3 is 3, so we've basically got to go 2, or 2 times 3 is 6. 3 times 6 is 18. God, they'll have to show me it. select all the factors of 20. Okay, what's a factor of 20? You can remember what a factor is? A number that can be times by itself to be, yeah, because a factor is a number and a prime number is something that can't be a factor. Let's have a go then. Well, 10 times. Oh my gosh, my brain. 2 times 2. Right, let's look up factors. What is a factor? What is a factor of 20? Oh, that's that thing where you have to do... I don't understand why I'm doing it though. So you start off with 20. And then it's 4 times 5 equals 20. And then they're going... I don't understand why it's doing it. That's why I'm never going to get anywhere on this one. This isn't teaching me anything either. So this tree thing that they're drawing, what is the point? I don't need the tree then. If I'm going to do it in my brain. So 1 is a factor. So 1 times 12. 1 times 20 is a factor. Two times 10 is a factor. 4 times 5 is a factor. Oh my gosh, and then you can also do negative numbers because you get a positive number when you multiply by 2 negatives. Oh my gosh. I just don't understand how they can expect you to learn from a rubbishy little video that lasted 1 minute without any explanation, just actually giving a fact, this is what happens. So I'm going to go 1. 2 times something will equal 20. 2 times 10, so... Is 20 is a factor of itself. 6, 12, 18. I don't know. For what? He's taking me to this rubbish page. Shows a really good page, and then when you go to it, there's nothing there. Well, this one says it's a composite number. This says it's a rational number. Yeah, no, I don't want to know what the factors are. I want to know why. You can get loads of stuff where it just says this is why. No, this is the factors of 20, but none of them like why. That's not helping. Oh, I see. So you do 12 times 1, and then 6 times 2, and 3 times 4, and you have to write like the 4, which is in the 3 times 4. So that makes sense. So 2 times 10 is a sum, right? 1 times 20 is a sum, and then you got 4 times 5, which is what I missed out, which is 20. That makes sense now. And then 18, we got 3 9s. This one needs to know my times table. I don't know why the 12 was there. Yeah, I don't know how many 12s you can factor to make an 18. 12 what? 2 12s, 1 12? Yeah, so know why that's wrong. What are the prime factors of 18? Select your answer. So they would be the prime numbers. Why 2 times 3, 2? What on earth does that mean? So this bit I kind of understand. So if you know your multiplication table, this is going to be really, really easy. And if you don't, you're just wrecked, because that means I'm wrecked. Just realised my screen. My screen has shrunk, so it didn't even make any difference really, so I might just put it back to what it was. Sorry about that, people. I'll just try zooming in on each page like that for you. Move that along as well. Oh, where are we? Oh, that can go there. Don't often need that. So let's find out what prime factors are. Do you need to remember start by dividing the number. So 228 divided by 2 is 114. Divided by 2 is 57. And you can't do that. Oh, I see. And you can't divide it by 2. So it's 319. But why are they writing it in the way they're writing it? So for 18, the prime factor of 18 would be, now I understand what the little branches are for, you're dividing it by 2, which gives you 9. And now you have to divide it by a prime number, 3, 5 or 7. Which is, so we divide it by 3. And then you put a 2 for some reason. I've no idea why that number 2's going there. I thought 3 is cubed like 3, or is it 3 lots of and another 3? No, is it 2 lots of 3 and then another 3? Yeah, because 6, 12, 18, 3 to the power of 2. Oh, just no, I've got enough to skip this because I'm going to get no work done. Right, the next one then. Let's have a look at this. Why didn't I choose something fun to do today? Right, 48 divided by 2 gives you... See, I can do that. That would give me 24. Which would be a 2 again, I suppose. Why is all this pretty writing for? Which would give 12, 2. I can write that in on the screen, couldn't I? Maybe not. Have I got, where have I got to put them? Oh, down the bottom. It'd been easier to put them in the thing. So that's 12. And then that will be 6 for the next one. And then there's 3. And that'll be a, I don't know. Let's say hello. Should I just say hello, my brain hurts? Well, Google says low key. Wonder what that means. Well, I can get some of this right, can't I? Because I know A is 24. I know B is 2. And I know C is 6. And I'm guessing that D would be how many times 3 went into 6. So that would be just 2 again as well. Like 2 times 3 equals 6. No, because then that's... No, because it's got to be times... 2 times 12 is 24. You're supposed to divide down until you can't do any more, aren't you? So 2 times 12 is fine. 6. 2 times 6. It can't be a 2, surely. So what's times 3? Oh, I see. It's 2 times A, which is 2 24s, yeah. I don't understand these arrows. They put me off. So B times 12 is 24. 2 times 6 is 12, which is that one. And then 2 times 3. Well, it must be a 2. Should we see if I'm right? Yay! I doubted myself, but there you go. 4 in a row, correct. See, my brain can suck this stuff in, even though it means nothing to me. Write a product as... So what I do is I have to write this out now. So for a write 48 as a product of its prime factors. Factor tree. Okay, so we start at 48 and we divide it by 2 until we get a decimal place. Because obviously if you do 3 and you divide that by anything, so that is the prime factor. If I remember that, I'm going to be amazed. Okay, next. Jilly's going to the seaside for the day with her family. Ooh, she's got a family and she's going to the seaside. If only I had that luxury. My keyboard is full of rubbish. Looks like I've got donuts all over it. Right, concentrate. Come on, Jilly's going to the seaside for the day with her family. It's 60 miles away. Why would you write the product of its prime factors? Oh, what is the point? Why? Why? I'll get a picture of that. When I go to college on Monday, I'm just going to look at the tutor and go, why? So Jill is going to the seaside for the day with her family. Nobody cares. But it's 60 miles away. That's the only fact. The seaside's 60 miles. So now you have to write 60 as a product of its prime factors. But why do you need to know? Just write what is the product of its prime factors. So let's have a go at that. Right, so 60. I don't think you can see any of this, so I'm just going to do it on my page anyway. Yes, it's got those number 2 things. I don't understand what all that is. So 60 times... Right, 60 2 times, and that'll be 30. I don't even know how to draw the trees anymore now. Oh, here we go. So, and then you would draw another line off for the 30 by the looks of it. How are you supposed to do this all neat? I've run out of space already. So it's 60 with a line, and that would be 2, and then that would be 30, so 2 30s, 2, and that would be 15, and you can't go lower than 15, can you? Oh, it's 3 19s 57. It's 3 times 19 57. Yes. Well, we can't divide it. Are we dividing those by 2 or 3s? Right. Start by dividing the first prime number 2 and continue dividing by 2 until you get a decimal or a remainder. Then I can go to prime numbers, but I can't. There's no number that comes to 15. So we got down to 2 and 15. Oh, 15, so 5s. But I don't understand 5. So the number would be 5 here, would it? Shall I write 5 there? And then that would be lots of 3. Or it'd be divided, which would be 7.5, wouldn't it? So it'd be 2 times 3 to the power of 5. No? Or would it be 5 to the power of 2? I have no idea. All I want to do is, it's 15. It's 5 times 3 is 15. So that, none of those questions mean anything to me. So I'm just going to leave that blank. What does it say? 2 times 3 to the power of 2 times... What's a load of crap? I'm not interested. Right, Jill parks her car and gets a ticket for 7 hours. Select the first 5 multiples of 7. So that's 1 7, 2 7s, 3 7s. Oh. 28, 35. 1, 2, 3, 4, 5. I can understand that. The family decide to buy. Who cares? Select the factors of 30. Well, a factor of 30 is 30. 2 times something. Ah, we're going to do this again. 2 times something. So 2 times 15. 1 times 30. 3 times 10. 5 times something. 6 times 5. Yeah, oh, that's good. 7's not going to do it. 12, no. 20, no. Let's try it. Oh, but if this is right, I've sussed that. Alright, go back. Let me have a look. Oh my god, I got them all right. How amazing am I? Let's put a yeah baby up there. Factors. Right, let's go more. of the shop, there are 3 different colour buckets and 6 different coloured spades. So there's 3 of that and 6 of that. What is the smallest multiple of both 3 and 6? So we multiply 3. It's 2, isn't it? No, we've got to get this right because it has to be a number that can come up with the same answer. So if we do 3, 6, 9, 12, 18, like that, and then we go 6, 12, it's there straight away. It's 6. No, not 1 6. It's got to be the same as the amount, hasn't it? That would be 1, 2, 3, 4 times 6. Right, let's do this properly then. So it's 3, 6, 9, 12, 15. Get the sums right. 18, 21, 24. Yeah, 1, 2, 3, 4, 5, 6, 7, 8. Do that again so I can fit them on the page. 3, 6, 9, 12, 15, 18, 21, 27, 30. So I've gone up to 10 times 3, which is 30. 3, 6, 9, 12, 15, 18, 21, 24, 27 and 30. And then we do the 6 times table, so it's 6, 12, 18, 20. So I've got 24 there. And they've got to be multiples of, so 3 times 3 would be 9, and that doesn't come up. So what about 18? We've got 1, 2, 3, 4, 5, 6. 6 times 3 is 18, and 3 times, oh, I don't understand this again. Let's have a look again for what? What are the smallest multiples? Multiples of 3 is 0, 12, 24. Multiples of 4 is 0, 12, 24. So it's the least common multiple. So it's 6. So 1 times 6 and 2 times 3. Shall we try that? Where are the first 4 multiples of 8? Well, they're quite easy, those ones, I think. 2, 4, 6. God, when I learn it, I'll just be able to type it that quick. I want to do my maths exam in a day. Please be right. I did exactly the same thing before. It's not the divisible. It's 8, 6. Right. The lowest to highest multiple. Look at the word. Is times the multiple, not divisible, not divide. And if it said divide, it would go from the lowest to highest. What are the divisible numbers by 2, wouldn't it? So it's the lowest to the highest. What are the first 4 multiples of 8? Did it like bam, 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 all wrong. Let's go. The family walk along the beat, right? They get 36 shells. Select all the numbers that are not factors of 36. Well, 36 is a factor, so that counts. 1's a factor, 2's a factor. So it's got to be, see, an odd number. 3 times 30 is a factor. 4, 8, 12, 16, 24, 28. Oh, do I need a calculator? Oh yeah, baby, give me that calculator. Is 36 divisible by 4? Because my brain's hurting. 36 divided by 4 is 9. So that is still a factor of 9. 6 sixes are 36. 8s. 16, 17, 20. Well, 8's not a factor of 36. Because you're like 8 plus 8 equals plus 8 plus 8 plus 8. Yeah. 9 is not a factor of 36. 12 is, so that's 10, 20, 36. 2 8s is 16. That is, so just those two. Come on, are you going to get this right? Can I cheering me on? You ready? Ah! 9 is a factor of 36. Well, how's that? Oh yeah. 4 9s are 36. You spad boy. Learn your tables. I'm gonna get them tattooed on my arm. Wonder if you're not allowed to take your arms into the maths exam if you've got multiplication tables on your arm. Oh dear. Oh, I finished. Should we go back? Let's do another one. What time is it? 2 o'clock. Index. Oh, who wants to do index of a number? Let's add. Index of number. Watch old man struggle. I'm going to mute my microphone and then play this back. Right, well, I understand now what a to the power is. So when I'm doing 5 to the power of 2, it's not just 2 times 5, it's 5 plus times 2 times 2. Because it's saying that you've got that. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. Like that. No, that don't sound right either, do it? Let's just get the, let's watch that again. Yeah, I was right. 369. Yeah. Okay, let's just go next page. Practice the skill. Square the following numbers. 2 by 2 is 4. 4 by 4. 4 times 4. 4 times 4 is 4 times 4. 16. 36. See, I'm going to get a bit stuck here now because my times table is 35. 49. This I should be able to do in my head because it's 1, 1, 1, 1, whatever. So it's 1 times 11 and 11, 121. And then 12. It's 244, I think. No, 144. It's lucky I worked it out, isn't it? Okay. That was nice and easy. What numbers multiplied by themselves give the following? Well, 1, of course. Three, 6, 9. That's, yeah. Oh, I need to know my tables. Oh. We could divide that by 2, which would give me 40 something. But that's not. I can do 10 by 10 is easy. I just don't understand that. It's like I don't know my tables. What could be 81? Timesing it by itself, like 9. Oh, it's a smaller number, and it'd be like 3 by 3 is 9. It's it to remember, doesn't it? So it has to be a cubed number. So you get 81. How can you get a cube? $81. Well, that's 6,051. And that's no good. I need to know the button to do it. I can't even use this calculator. Should we get a times table chart up on the screen to assist me? Looks like my there we go. Times table chart. Yes, I pressed that now. Come on. So we just basically got to look for an 81 nines 9 by 9. So if I knew my tables, I could have just spanked that in straight away. So the fact that I know what I'm looking for, but to remember all those numbers is a 10 by 10 is 100 numbers, isn't it? To remember it shouldn't be that hard, considering most of them I don't need to know. Easy way to memorise the times table. Yeah, half of them are exactly the same. Right, cube numbers. Let's write all my cube numbers out and print them out. I think it's about time we did that. So we got which ones did that lady say to remember? I think she said to remember the first 9, didn't she? I ain't got time for this. Right, let's just get an answer, right? Thank you. Bradley had some friends to go to a concert in the park. The stage is square shaped. Each side is 8 meters in length. What is 8 times 8? Whereas my maths timetable, my maths thing, I want that printed out. Can we print that? I don't want Pinterest. Go away, Pinterest. Okay. Let's do... print screen on that. Add image. Wow. Can we line that up to the left? We can insert some text. What was it called? That, my friend, is so tiny, but will be absolutely awesome. I can't even see that. There you go. I doubt you can read that. That is so tiny. And let's add in there and put cube. Cube numbers. Cube numbers. List. So we've got no, it's alt code, isn't it? Alt code for power of 3. Alt 0179. So none of them are there. They just talk. Why does YouTube just or Google send you to stupid places? Well, we just add the power of 3 and it's not showing. Right, there's a half. There you go, 253. So if we copy that, we can go just put the 1 there. 1's the power of 2. Equals 1. Power 2, yeah, equals 4. Actually think we'll cut that and just print that out. Wish you could stretch that. Can't stretch it, can you? Delete that. That font's pretty rubbish, isn't it? Let's change that font to something simpler. Arial. Yeah, looks good. And we'll rotate the sticker. Can we rotate the sticker? Must be a rotation button. Oh, let's try. Well, that works, but I'd like my screen to be showing. No. So this is the label. Yeah, I'll be back. believe my microphone was on mute. Sorry about that. So 4 squared, let's see if I can get this right, would be 4 plus 2 lots of 4, which is 4, 8, 12. No, it's not, is it? Is it 4 lots of 4? 4, 8, 12, 16. Yeah, so it's 2. It's just 2 times 4. That can't be right. No. Let me just put the answer in. I know what the answer is. Let's work this out later. We could make these much smaller. Yeah, you can't change the individual font. It's a bit rude, isn't it? So 25s, that'd be 5 by 5. 5 5s are 25. Oh, so you're timesing it by itself then, aren't you? So 2 by 2 is 4. 3 by 3 is not. But that doesn't work there. It works on 5. 5 times 5 is 25. 3 times 3 is 3, 6, 9. Right, so 5, 10, 15, 20, 25. So which one didn't work? 6. So if I went 6 by 6, it's 36. 6 times 6. This is what we're doing, cubing, aren't we? It's like the area or something. And 7 by 7s are 35. It's 49. So is it 7 sevens or what? What have we got here? 7 by 7 is 49. So 8 by 8 is going to be 64. 9 by 9, that's less than 10 by 10. See, 10 by 10 is 100, that's easy. 9 by 9 is going to be 81. And then 11 by 11 was the 121 we did earlier. Oh, we're running out of space now. Let's put one of those up there. One up here, and then one up there. Okay, 11, 12 by 12. They're not really lined up very well, are they? They're not lined up at all, but that's cool. And that's me 144. So they're literally 7 to the power of 2 is just that. Does that go across the times? 1, 4, 9, 16, 25, 30, no. 81 and 64. 49. So yeah, it's that line of numbers that runs down diagonal. What were these called again? Square numbers. Let's do another insert text. Add text. And then we do square numbers. I can stick that right down there. Oh, square numbers. We didn't ask for that to be that many times, did we? Right, square numbers. We're having trouble squeezing that in that little gap. Yeah, that's good. Right, let's save that. Oh, we'll print 5 of them out. I've got loads now. Look at this. Let me just have a look if anyone's been talking to me. I doubt it very much. Ooh. Hello. Pennywise, I'm sorry, but I don't have timestamps, so I'm not sure when you said what you said. I should definitely be going on a very, 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 very long walk later to clear my brain. So I do about 3 to 4 hours of studying a day, but I like to pick the stuff now that I've no idea what I'm thinking of doing, if that makes any sense at all. It's a shame there's no timestamps on the video. Right, let's just leave that in my thing with the lid shut. I'm glad I didn't do this at the library. I would have been quite really struggling at the library. Right, so we've done the square numbers. I've got a little print out of those, which I can try and memorise, like 2, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. So if I can remember those, wonder if there's watch old man struggle with maths. A rhyme to remember first 10 square numbers. What is wrong with people? You ask for a simple thing and oh my god, mnemonics for squares and cubes of 2-digit numbers. I was taught for mental calculation. I've never been particularly fond of mnemonics. That is, methods for memorising numbers by word association or letter patterns. Perhaps I would be if I were a performer called upon regularly to recall numbers. One of the most powerful tools in mental calculation is converting the multiplication of two different numbers into the square of the average minus the square of the difference. This is shown by algebraic identity. But I'll tell you, I'm 50 odd years old. I've never had to do that. Mnemonics, alphabets for digits. M. 3. Oh, N has 2 downstrokes. Oh, I see. So ham becomes an egg is 2, 7. What on earth is this bloke on about? Oh, I see. So you, instead of remembering the numbers, you remember the letters. So 3 is ham. Because why? Right? This bloke's written like a 30-page manual on how to remember the first 10 square numbers. This bloke's mad. Let's get this off and finish this maths off. We'll save that. Save as. Square numbers. Let's get back to some fun. Try not to skip too far. So we got back to the 8 times 8, which is 64, isn't it? 64. Well, I can work that out. I'm going to say 64, because that's the size of a chessboard as well. Thank you. Next. Cube the following numbers. 2 bar 2 is 4. No. Ah. It's not. Is it? It's 2 by 2. Yeah, so that's 4. Now 4 by 4 is not, is 4, and then another 4 and another 4 and another 4. So it's 4 times 4, which is 4, 8, 12, 16. So that's 4, 8, 12, 16. And 6 is 36. So it's 6, 12, 6 times 6. Yeah, it's 36. Oh, you're right. Oh my god, every single one is wrong. Oh, all this time learning and I know nothing. Oh, it's cube. Oh my god, they tell you you're sitting there doing squares and then you're on cubes. Oh. Fill your head up with all this stuff and they just, as soon as you've learned it, you don't get any more practice. So a cube is 2 bar 2 bar 2. 2 times 2 is 4. Times 2 is 8. 4 times 4 is 16. 16 times 16 is 64. 6 times 6 is 36. 6 times 36 is, I said that wrong as well, 216. Right, I know that one anyway. I just got to read the question. Right, what numbers are multiplied by themselves 3 times to give the following? Well, 3 lots of 1. Well, 3. 7. No. 27's not 7 3 times. Oh, what's by itself? So that I'd need to look that up on my tables again. So for 27, that's 3 times 9. But is there another 27 in there? Oh, so no, yeah. What numbers multiplied by themselves give the following? Well, that's 9 times 9. No, there isn't any other 27. That doesn't make sense. Because even on that chart I'm looking at, the only way I can see the number 27 is 3 times 9. Or 9 times 3. Well, a number that's multiplied by themselves 3 times give the following. So 9. So it's saying what number multiplied by itself. So you could lose the themselves bit and I'd understand. So what number multiplied by 3 gives the following? Will be 9. Oh, why'd they make it so... Ugh. So 125 isn't on the multiplications table. So you could divide that by 3, couldn't you? So we do 3's into 125 because that's the only one I'm going to work that out. 3, 6, 9, 12. That's 40. And that doesn't work out. You can't have 41 point something. You can't have 25. Can't have 50. It's not divisible by 3. 125 is not divisible by 3. Even my calculator will tell me it's not divisible by 3 unless I've gone proper thick. 125 divided by 3 equals 41.666. Whereas if I go 27 divided by 3, that gives me 9. Just put nothing because I don't know. 5? What? What numbers multiplied by themselves 3 times give the question doesn't even make sense. 3 times what? 3 times 3 times 3? Is that what they're trying to say? Just I don't understand the question. So what numbers multiplied by themselves? So you put a number. So let's see if we can write that out. So you put a number 3 by themselves 3 equals 9 3 times 9 is 27. This is not going to be fun, because that just doesn't make any sense to me when I'm reading it. So I still don't understand how 5 is. So 5 times 3 equals 15. No, it's 5 by 5 by 5. Yeah, 5 by 5. So why don't they just put flipping cube up on it? What number gives the cube root of 125? That would be more sensible, like 5 times 5 times 5. Well, that's 5 times 5 times 5. We just had that on the last one, wasn't it? 5 cubes. See, when you ask the question properly, well, I think I'm done now, because this is just doing my head in. See where we got up to. Well, we done calculations, and so the last one, let's do order of operations, and then we can go in and do a skill check on Monday at college. Muting my Right. So let's see if we got that right. Our BIDMAS. So 5 plus 9 times 4. First thing is multiplication. So it's 9 times 4. Let's put the brackets in. 5 plus 9 times 4. Brackets. 9 times 4. And that will give me 36. That's 5 plus 36. Right. So let's see if we got that right. 5 times 36. No, 5 plus 36 is 41. Right, the next one, 8 times 5 minus 7. So we have to do that 8 times 5, which is 40, minus the 7, and makes 33. And now we got this 22 plus 3 times 4 divided by 4. Now that means we have to do the 3 times 4 first. No, we do division first. So we do 4 divided by 4, which is 0. Wow. That looks like it's not going to go right, but we'll just do it anyway. So 22 plus 3 times 4 divided by 4 equals, so 4 divided by 4 is 1, isn't it? If you've got 4 things and you divide it between 4 people, you get 1. And then 3 times 1 is 1. 22 plus 1 is 23. I'd like to do that on my calculator first, just to see whether my calculator is clever enough to remember to do it in the right order as well. 22 plus 3 times 4 divided by 4 equals, I got 25. Or did I do different? Should we put the brackets in how I did it? 22 plus 3 brackets 4 divided by 4 brackets. Does that look right? I still got 25. So where did I go wrong then for getting 23? Let's do this right. 22 plus 3 times 4 divided by 4. So we're definitely doing the brackets. 4 divided by 4 is 1. 3 times 1 is 1. No, 1 times 3 is 3. Plus 22 is 25. Okay, that's where I went wrong. So it'd have been annoying getting that wrong just because I didn't do my maths correct. So I've got to be really careful with typing stuff in correctly. Oh, subtitles on my channel. Mr. Baldy is very happy. Get off the screen, mister. Okay, let's do this one. 3 times 6 minus 44 divide without looking at the BIDMAS 11. So the first thing to do is the division, which is 44 divided by 11. Put brackets around that. 44 divided by 11 is 4. And then the multiplication, which is 3 times 6. That's 18. And we're left now with 18 minus 4, which is 12. Ooh, let's have a go on the calculator again and see how we got on with that. 3 times 6 minus 44 divided by 11. My calculator just does it. I got 14. So I've done something wrong again. Let's have another go. Let's do it again. 3 times 6 minus 44 divided by 11 equals, so 44, 3 times 6 is 4, 6, 12, 13, 14, 15, 16, 17, 18, minus 4 is 14. Yeah, so you get your maths right. I'm not sure why I can't work out. Maybe I'm just getting tired in the head from thinking. It's a bit of Coca-Cola. I think I'm gonna be stopping in a bit anyway. Oh, you filthy man. Brackets, indices, division, multiplication, addition and subtraction. That man tried to teach me that. Now in the brackets, this one down here, it means you have to do the brackets first because that's what BIDMAS says. So brackets 15 minus 3 divided by 4 plus 6. So we do the brackets first. So 15 minus 3 is 12. We then do the division, which is divided by 4. So that's 12 divided by 4, which equals 3. And then you add 6 to the answer, which gives you 9. And we'll do that on the calculator just to be sure, because if I do it the wrong way on my calculator first, so 15 without the brackets minus 3 divided by 4 plus 6, that comes to 20.25. I forgot my answer now. What was my answer? Oh, well, that was 12 minus 3. Yeah, which was 9 plus, oh my gosh, I've just messed it all up. I'm gonna have to do this again. Right, 15 minus 3, that's 12. You then have to divide that by 4, which equals 4, and plus 6 equals 10. So that's my answer, 10. And obviously if you do it the wrong way, it doesn't work. So let's write it exactly like that in the calculator. 15 minus 3 divided by 4 plus 6 equals 9. I got 9. Why have I got 10? I don't like it if I don't know the answer. Definitely going to move my webcam down here lower. Don't like it over there. I've got a hole in the table for it as well. You are not going to... Oh, it's because it's 7... Oh no, that's a different sum. Right, let's do it again. 15 minus 3. Do it all on a calculator, one step at a time. 15 minus 3 equals 12. Right, 12 divided by 4. Divide that by 4 equals 3. Then we're plussing 6, which is 9. So the answer is 9. Did I put 10? Why did I have 10? Brain is hurting. equals 12. Right. 12 divided by 4 equals 3. 3 plus 6 equals 9. Now, is that what I was getting? I wonder if I was getting that in the thing. So 15 minus 3 divided by 4, 6. I got the same answer on my calculator as I did on my workings out, and there is my workings out. Now it gets a little bit more complicated. Let's try this one. No calculator. Brackets first. 17 minus 8 times 10. Oh, this one looks easy. Minus 6 equals. Well, that's 17 minus 8, which is 9. 10 minus 6 is 4. And then 4 times 9 is 36. Okay. So let's put that in there. And I'll do the calculator as well, just to be sure. So we do 17 minus 8 equals 9, yes. 10 minus 6 is 4, yes. And then we'll do 9 times 4, 36. Right, who's going to reckon I'm going to get all these right? Oh, yeah, get a photograph of that. Send it to my son who doesn't care. Let's go back to the tough ones. Oh. Looks like you can only go back to the video. Oh, this is not going to be fun. Right, well, I am happily going to say that I am not even going to look at those today. Brackets first. See, that's the thing. If I looked at this sum the other day, I still would have done that. But you'd actually have to know what 4 to the power of 2 is anyway, wouldn't you? Which is 16. Let's just do that, yeah? 4, 8, 12, 16. So why they can't just put 16 there is, I don't know. So we would do the indices first. So that would be 16. So we'll do 16 minus 5. 11. Okay. And then we'll do the division next, because that's the next thing. I know you do the brackets, indices. So yeah, that's what I was doing anyway. So 21 divided by 3. We know that's 7. Don't know why I'm doing that on the calculator. And then it's 7 plus 11 plus 11. That would give me 18. So let's type that in my calculator exactly how it is on screen. 21 divided by 3 plus 4 power of 2 minus 5. I don't even know why I'm doing this. It says syntax error. Well, that wasn't any good then, was it? Let's try it again. 21 divided by 3 plus open brackets, 4 to the power of 2 minus 5 close brackets. That's pretty much what I wanted to put there. And that should come out to 18, no 11, I can't remember now, 11. Let's press it. 18. Well, I don't even know where 11 came from anymore. But yeah, it's gonna be in there. But we'll do that again tomorrow. But that's pretty cool. For me, doing stuff like that's amazing because I have no idea. Let's go home. Yes, please. What's this? Course view, achievements and resources. Well, that is it. Oh, shouldn't really be showing that. Let's get rid of that. Thank you all for watching. All that typing for one sentence. God, you love Tangobaldy. Right, thank you very much for watching, and I will really be back very soon. I'm going to go out for a little walk now because my brain is broke. So, bye.